All right, so can I get my pen to work? I'm gonna do this problem for you. This is the second part of section 5, or 4.5, excuse me. Example 6. And how do we solve this? So first, when I look at this, I notice that there's 2 logs on one side of this equation, right? And then there's 1 log on the other side. So my strategy for solving for this is I know that if I can get log of A on one side equals log of B on the other side, if I can reduce it down to 1 log on each side, then I can say, hey, A equals B, right? That's a property that we can use. So that's what we're going to try to go for. So I need to condense this down on one side. I need to say, can I express this as a single logarithmic function? And you can, or a single log expression. And this is x plus 6 divided by x plus 2. And that equals log of x. Now, since I have 1 log on, it's the log of this thing equals the log of this thing. Now I can say x plus 6 over x plus 2 is equal to x. All right, now something to note right here. Anytime you have a variable in the denominator at any step, I could have done it at this step right here, but I got to remember that x plus 2 cannot equal 0 because I can't divide by 0, right? Which in this situation means x is not equal to -2. So if I get -2 as my answer, that would be an extraneous solution. I need to be careful of that. That's one reason. Anytime you divide by 0, if there's a value that would cause you to divide by 0, you can't use that value. But let's keep it moving. Here, I'll just multiply both sides by x plus 2 to get rid of this fraction. And I got x plus 6 equals, I can distribute that and say x squared plus 2x. Because I see an x squared, that means it's quadratic, so I need to solve by trying to factor or using quadratic formula or something. Regardless, I need to get it all to one side. So I'm going to move my x and my 6. And I have 0 is equal to x squared plus x minus 6. And now I'm going to try to factor this. I'm saying 2 numbers that I multiply together to get -6 that I can add together to get +1. So that's going to give me a +3 and a -2. This right here means that x is equal to -3 and x is equal to +2. So now am I done? Not quite. I got my answers, but I need to check for extraneous solutions. Now, this is a different situation. If I got x equals -2, yeah, that would be extraneous right there. But I also have to remember that I cannot take the log of a negative. If you have the log of a negative, that means that you got to throw that away because you can't have the log of a negative. That was in my previous video. We talked about why. Okay, so let's plug these numbers in. And right out the gate, I see that -3, if I plug that in here, -3, then I'm saying that's the log of a negative. So I know that -3 is extraneous. What about 2? 2 plus 6, that's positive. 2 plus 2, that's positive. So the only solution I have here is x equals 2. Got to be careful for those. All right. Let's try this one. This is a good time for you to pause the video and try it yourself. But I'm about to get it, so I'm going to do it pretty quickly. I can say this is log of x times x minus 21, because that's the product property, equals log of 100. I can get rid of the log and say x squared minus 21x equals 100. Say x squared minus 21x minus 100 equals 0. Try to factor. Two numbers that I can multiply together to get negative 100. And when I add them together, I get negative 21. That's negative 25 and positive 4, which means that x would equal 25 and x would equal negative 4. I would be finished, but I gotta check for my extraneous solutions. So 25, log of 25, that's positive. Log of 25 minus 21, that's still positive. Log of 100, that's positive. So this one, I know we're good there. That's a check. Log of negative 4, right out the gate. Since I have to plug a negative 4 in here, watch what I'm saying here. Log of negative 4. Well, I'm trying to figure out, at one point, I'm needing to figure out what that equals. This is understood to be a 10, so 10 to some power is equal to negative 4. No way. That doesn't happen at all. It can't happen. This is extraneous. All right.